In this last lesson, we're going to put all our factorings together and understand that sometimes polynomials have more than one type of factoring involved. But before we do that, we're going to name a specific type of factoring that we've already been doing, and it's the factoring when there are four terms, and you group it into pairs, and you factor out the GCF of each pair, and look for a common factor. That should sound familiar because we did it in the lesson where the a value is greater than 1, but the official name for it is factor by grouping. So we already know this technique, so hopefully it shouldn't be that challenging. We're going to look for the GCF of this first half, which would be x squared. So that gives us x squared times x plus 3. Then we go to the GCF of the second half, which is positive 2. And when you divide that, you get x plus 3. Since we have the same thing in both parentheses, we know that we can combine it and finish our answer. It's going to be x squared plus 2 times x plus 3. All right, let's do the next one. Same technique. We're going to do the GCF of the first half, which is x. So that gives you x times x plus 1. And then you do the GCF of the second half, and that is y. So you get plus y times 1 plus x, which feels different, but remember it's the same thing. X plus 1 is the same as 1 plus x. So final answer, x plus y times x plus 1. Not every single polynomial is factorable. So you've seen ones that look like this, x squared minus 1. That was what we call the difference of two squares, right, like that. But x squared plus 1 cannot be factored using any of our techniques. So what we call that is, get this, not factorable. I know, crazy. What a weird name. So when we say to factor a polynomial completely, which is really what you should always be factoring, we have it written as a product of unfactorable polynomials with integer coefficients. So what that means is, if you look down here, we'll look at this concept summary in a second, but if you look right here, let's say that you only pulled out a 3, right? If you look at the answer, it has a 3x. But let's say you just pulled out a 3 and you did x squared plus 6x. The piece right here in the parentheses still has a GCF, which means it's not factored completely, meaning you can still pull out some sort of factor. So that would not be factored completely. What we want to do is we want to have it look like this with a 3x, and then x plus 2 can't be factored anymore, so we stop there. So when you're trying to determine how to factor something, you want to look first for GCF. I told you that in a previous lesson, always look for GCF first. Okay, then if it's a trinomial, you look to see if you can use our double bubble techniques. Or if it's a 4-term polynomial, you look to use the grouping techniques. And you keep checking your answer to see if you can keep factoring, because sometimes there's more than one type involved. So let's look at example A. What's the first type of factoring you always look for? Hopefully you said GCF. So let's divide out the GCF here. So you pause for a second, you look for a GCF of the numbers, GCF of the variables, and the GCF here is 3x. So I'm going to do 3x times x squared plus 2x minus 6. And then it's one of our basic trinomials. So we're going to look for factor pairs that multiply to -6 that also add to 2. So I get, let's see, that is going to be, 6 and 1 doesn't give me 2, 2 and 3 doesn't also give me 2. So actually, this is factored completely because that trinomial is not factorable. The factor pairs of -6 don't give you positive 2. Remember, that's our rule. We have to multiply to -6 and also add to 2. Since I don't have an integer pair, this actually is as far as you can go. Crazy. All right, let's check out the next one. we're going to do a GCF of 7x squared. So we get x squared minus 4. And I have a binomial, so I'm going to check for difference of two squares, and it is. So this is x plus 2, x minus 2. Bring down the 7x squared, and then you look at your terms and you say nothing else can be factored, so I'm done. You can put all of these pieces together by factoring and then solving, but remember, in order to solve and in order to factor, it has to equal what number? 0. Good. So the first thing that I need to do is I need to move this 10x over to the left. So I get 2x to the third plus 8x squared minus 10x equals 0. Now I can factor, and then after I factor, I can solve. So let's look for GCF first. I'm going to divide by 2x. So I get 2x times x squared plus 4x minus 5. And let's see, factor pairs that multiply to -5 that also add to 4. It's going to be +5 and -1. So I've got x plus 5, x minus 1, bring down the 2x. Now, if it just said to factor, I'd be done, but it said to solve. So what I have to do, I'm just going to write it up here because I wrote super big. Is now I need to drop my line down all of the factors to see what my values of x could be. So 2x could be 0, x plus 5 could be 0, or x minus 1 could be 0. So if the 2x is 0, then x is 0. If x plus 5 is the 0, then x is -5. And if x minus 1 is the 0, then x equals 1. All right, let's check out example 4, the last one together. Read the story, and then press play when you are ready. So really, the only thing that they gave me that is super helpful right now is the volume. They gave me this like random fact that the length is more than 10, so that might be helpful later. Maybe I'm going to get 2 answers, and one will be less than 10 and the other will be bigger than 10. That's just my thought. But what we can do is we can use this number for the volume. So remember, volume of a rectangular prism is length times width times height. So I'm going to use that idea, and it's just going to be a little more complicated with polynomials. So it's going to be 36 minus w times w plus 4. Okay, no big deal. That's going to equal 4,608. So I'm going to take my idea, and I'm going to distribute what I have. And just like with numbers, you're only multiplying 2 at a time. So really what I want to do is I just want to take this and I want to multiply these 2 pieces, and then I'll worry about w plus 4 later. So when I multiply by w, I get 36w minus w squared. And now I'm going to multiply that by w plus 4. Okay, let's keep plugging along. I'm going to use the box technique to multiply those 2 binomials. So here we go. 36w negative w squared w 4. All right, so 36w squared, 36 times 4, 144w. That's going to be negative w to the third, and that's going to be negative 4w squared. So when I combine them, I'm going to get, I'll put it in standard form, negative w squared plus 32w, oh, sorry, no, negative w to the third. Almost had a blooper there. Plus 32w squared plus 144w equals 4608. And I might not know what to do here, but I know when in doubt, set it equal to 0. Now I could, watch this, I could bring this 4608 over, but then I'll still have a leading coefficient negative. So what I'm going to do is I'm just going to take all these things and just move them over to the right. It doesn't really make the math any more complicated. You just move it over to the other side. So I have 0 equals w to the third minus 32w squared minus 144w, because they all had to change signs when I moved them over, plus 4608. Okay, now I have a 4-term polynomial, so my method is grouping. So the GCF here is w squared, and the GCF here, I have no idea. Is it 144? Yeah, so I can divide both sides by negative 144, and then I'll get negative 144 times w minus 32. Almost there. Let's put it all together. I have w squared minus 144 times w minus 32 equals 0. And this is a difference of 2 squares, so I can keep going. Ooh, this question is quite a doozy. So I get w plus 12 times w minus 12 times w minus 32 equals 0. Okay, so my 3 values of w are w could be negative 12. Well, that's stupid because you can't have a negative with. W could be 12 or w could be 32. How does that help me? Well, if w is 12, then this is 12, 16, and 24. If w is 32, then this is 4, 12, and 36, but it says the length is more than 10, that fun fact from before, so therefore it can't be 32, so w has to be 12, so my dimensions are 24, 12, and 16. Whew, that was exhausting. All right, we're going to talk about this one definitely in class because it is super crazy. Like, my mind is exploding right now. So if you have any questions, write them down and ask me when you come to class.